In this video, we're going to look at some examples of different types of data. So the types of data that we talk about in this class are quantitative, which is numerical, or qualitative, which is also called categorical. We're going to do this by looking at a couple of different data sets in StatCrunch. So if you go to our class group in StatCrunch, you can follow along with this if you'd like. The first one we're going to look at is heart attack survival data from 1993. If you look at the description of this data set, this will tell you a lot about the different variables in the data. For one thing, it tells you what this data actually is, where it came from. So this is all hospital discharges in New York State with an admitting diagnosis of an AMI or a heart attack who didn't have surgery and did not die in the hospital in the year 1993. Since this is all of these people, then this is actually a population instead of being a sample. And it says there are 11,434 cases, which means when we look at the number of rows in the data set, that's how many rows there will be. And then it gives you information about the different variables that are in the data. Now we're going to look at each of these variables and decide whether it's quantitative or categorical. Over here, I'm just going to list these different variables. So we have age and sex, diagnosis, DRG, which is another type of diagnosis code. And then it has LOS, which stands for length of stay. That's the number of days that the person was in the hospital. Charges is the total amount of charges they were charged. And then there's a last column that also has to do with the gender of the person. It's just coded as zeros and ones instead of F and M for female and male. So those are all of our variables. And when we look at the data, we'll see that there's another column at the beginning here which wasn't listed as one of the variables, where it says patient number. The reason they didn't list this as a variable is that it really isn't. It's really just an identifier. Since it's a column in here, I'm going to write this in here also. But when we talk about the type for this, I'm going to put over here that it's not really a variable, it's just an identifier. Okay, so let's go through this list of variables and determine whether we've got a categorical variable or a quantitative variable. The first one is age. Now, age is a numerical variable and it is quantitative. Now, it's also possible to have categorical variables that are represented by numbers. The way that you can tell the difference is whether you can do calculations with the numbers and get something that has a meaning. So for example, with age, we could do things like find the average, find the standard deviation, some of the things we'll talk about in Chapter 3, and those would mean something. We could put our patients in order by their age, and that would also be meaningful. So this is a quantitative variable, and then we can also look at, for the quantitative variables, we can also look at whether they're discrete or continuous. One of the ways you can tell it's discrete is if it answers the question, how many? In this case, we could look at it that way because we're asking people how many years they've been alive. And this one, because people answer their age with just a number, they don't give exact duration of how long they've been alive, this would actually count as a discrete variable. Okay, then the next one is sex, and this is just coded as an F for female and an M for male. First of all, because it's not numbers, you can tell right away it's a categorical variable. Then for diagnosis, this one's a little bit tougher because it is given as numbers, but if you think about the meaning of these numbers, these are standing for specific diagnoses for the patients. That would make it categorical. Another way that you can tell it's categorical, again, is if we did things like averages of these numbers, that wouldn't give us anything meaningful whatsoever. So this is a categorical variable. because it divides our patients up into different categories depending on what their diagnosis is. Same thing for the DRG. That's another form of diagnosis code. And in this data set, we actually only have two different DRGs, the 121 and the 122. One of them was with complications and the other one was without complications. So again, this is dividing our patients up into two different categories, so it's categorical. Then we have the LOS, which stands for length of stay. So this is the number of days that the patient stayed in the hospital. Now this is numerical, and we could do things like find an average length of stay, things like that. So this is a quantitative variable. And we also want to look at whether it's discrete or continuous. This is answering the question of how many days they spent in the hospital, so this would be discrete. Okay, then we have charges, which is how much the patient was charged for their hospital stay. This is definitely a quantitative variable. Now for this one, this is also actually a discrete value because the furthest that we're going to measure this is down to the penny. Another way that you can tell that something's discrete is if there are gaps between the values. This is not a measured value, this is something that was counted up. The amount of money that they owed was counted, and there are gaps between the possible values from one penny up to the next penny. So this one is also discrete. Then the last one is this last column that says sex 1. This is the same as the sex column over here, only it's been converted to zeros and ones. So for this one, even though it's numerical, it's still representing categories. So it's a 0 for a female and a 1 for a male. So this one would also be a categorical variable. Okay, now we're going to look at a different data set, and this is the low birth weight set. So again, if we want to see what some of these things stand for, if we can't tell for sure, they have a long description in here about what these different things are standing for. So again, let's go over here and list all of our different variables. So we have age, which is the age of the mother in years. We have weight, mom. We have DR visits, which is the number of doctor visits in the first trimester. We have birth weight, baby's weight at birth. A smoker, which is the mother's smoking status during pregnancy. Race mom, which is the race of the mother. Low BWT, which just says whether the baby was considered low birth weight or not. And that's all of our variables. So now let's look at these and just go through and decide what type of variables they are. Age, their age in years. So again, this is quantitative and it's discrete. Okay, then we have weight mom. This is the weight of the mother at her last menstrual period. Even though there are gaps between the numbers, for example, we've got 107 pounds and 108 pounds, since this is actually a measured amount, this is actually a continuous variable. So this is quantitative and it's continuous. And one good way to tell about that is if it's a measured value, then it's almost always going to be continuous instead of discrete. Okay, the next variable is doctor visits. And this was the number of doctor visits during the first trimester. So these are definitely numerical values, which makes it quantitative. And then you can't have 1.5 or 1.2 doctor visits. So this one is discrete. This answers the question, how many? How many doctor visits were there during the first trimester? The next one is birth weight. Again, this is a weight in grams and it's a measured value. So this is quantitative and it's continuous. The next one is smoker, and this is just whether the mother smoked during pregnancy or not. This is answered in words, so it's definitely a categorical variable. Race mom, this gives the race of the mother. Looks like we have black, white, and other. So this is a categorical one also. It divides the mothers up into categories. And the last one is the low BWT, which just identifies whether the baby was less than 2,500 pounds or not. So here we have a bunch of no's. If we scroll down in the data set, all the yeses, so all the low birth weight babies are down here. So since this is just two different categories of whether they are low birth weight or not, then it's a categorical variable. One of the reasons that this is really important is that we will do different things with variables depending on whether they're categorical or quantitative. So if we have a quantitative variable, we can do things like find averages, means, medians, standard deviations, those kind of numerical statistics we can find. If it's a categorical variable, then we can't do those things. We tend to do different things like look at percentages. So for example, what percent of the babies in this data set are low birth weight, or what percent of the mothers were smoking during their pregnancy. That's the type of things we tend to do with categorical variables instead of the other things that we do with quantitative variables. So that's why it's really important to identify what type of variable you have.